Hello students, for today's class we are going to talk about chemical families, patterns and properties, understanding the structure of the periodic table. Therefore, from our previous class, we learned about the elements in the periodic table are classified according to the number of valence electrons and the number of occupied energy level into groups and periods respectively. Elements in the same group are said to belong to the same chemical family. In this chapter, we are going to talk of the four families considered in the details, trends in the physical and chemical properties, provide useful information in the predicting the physical and the chemical behaviors of the elements within a family. Introduction of the topic, the elements in the periodic table, which I said in previous, according to the number of valence electrons and the number of occupied energy levels into groups and periods respectively. Elements in the same group are said to belong to same chemical family. Therefore, for the table below, there is a periodic table which shows the chemical family. Therefore, it's a group or a column that contains elements within similar properties. Group 1, alkali metals. Group 2, alkaline earth metals. And group 17, halogens. But we are going to focus on, for today's lesson, alkali metals. These are group 1 elements. They are called alkali metals because they react with water to form alkaline solutions. They include lithium, potassium, calcium, fractium. They have physical properties. We have a shiny metallic luster when fresh cut, soft and easy to cut. However, the surface quickly tarnishes because it reacts with air. The alkali metals are soft and easy to cut. The softness and ease to cut increases down the group. This is due to the decrease in the strength of the forces holding the atoms together. As you move down the group, the alkali metals have relatively low melting and boiling points. The melting and boiling points decreases down the group. This is due to the weakening of the forces holding the atoms together. The strength of the forces holding atoms together depends on the size of atoms. The larger the atoms, the weaker the forces. Thus, as the atomic radius increases, the force of attraction between the atoms weaken. Hence, the decrease in the melting and boiling points down the group. Alkali metals are good conductor of heat and electricity. Conductivity in metals is due to the presence of the localized electrons in the structure of the metal. Since they all have one electron in their outermost energy level, their conductivity is similar. Ionization energy. This is the minimum energy required to remove an electron from the outermost energy level of an atom in the gaseous state. Down the group, from lithium to potassium, the first ionization energy decreases This means that electron from the outermost energy level of potassium atom than of sodium and a lithium atom. This is because the effective force of attraction of the outermost electron by the positive nucleus decreases with increased atomic size and the distance from the nucleus. In metals, the electrons in the outermost energy level move randomly throughout the metallic structure, since the electrons do not remain in one fixed position. They are said to be delocalized. After done with the physical properties, we are going to talk about the chemical properties. Chemical properties. In Book 1, Chapter 4 and 5, the reaction of potassium and sodium metals with both air and water were discussed. Therefore, in this section, the chemical properties of alkali metals based on those reactions shall be reviewed. For safety purposes, very small piece should be used in this experiment we are going to carry out. Lithium, sodium and potassium react vigorously with both air and water. Potassium is the most reactive and lithium the least reactive. Sodium is exposed. It reacts with the moisture in the air to form sodium hydroxide. The sodium hydroxide further reacts with carbon dioxide in the air to form sodium hydroxide. Therefore, we can look for the reaction of alkali metals with water. Lithium floats in water, while sodium metals that's on the surface of water. Potassium, the metal, that's above on the surface of water and melts into a silver ball, while sodium melts into a silver ball. Then, for lithium, a gas is produced. For the rate of reaction, lithium reacts vigorously with the water, sodium reacts more vigorously, while potassium reacts explosively in the water. Therefore, after the chemical and physical properties of alkali, we are going to talk about gradation in size of atom and ion. Gradation is majorly pointed on the atomic radius. Now we can define the atomic radius, which is the distance between the center of the nucleus of an atom and the outermost energy level occupied by an electron or electrons. The atomic radii and ionic radii of alkali metals increases down the group. This is because each alkali metal has one more occupied energy level than the preceding member in the group. Lithium has 2 energy levels, sodium has 3, while potassium has 4. Therefore, in the periodic table, lithium is number 3, sodium is number 11, while potassium is number 19. There we can write them using the electron configuration. For lithium, 2 to 1, while sodium 2, 8 to 1, while potassium 2, 8, 8, 1. Therefore, the outermost electron in the sodium atom is therefore further from the nucleus than the outermost electron in lithium. This explains why the atomic radii of alkali metals increases down the group. when an atom loses an electron to form a positive charged ion, the remaining electrons experience greater nuclear attraction. The remaining energy levels move closer to the nucleus, resulting in a reduction in the radius. An alkyl metal forms an ion by losing the single electron from the outermost energy level. The resulting ion, which is the cation, has one occupied energy level less than the corresponding atom. Hence, the ionic radius of alkali metals is less than the atomic radius. Briefly, we can look on how alkali metals react with some compounds, e.g. chlorine. When hot sodium metal is lowered into chlorine gas, the metal burns into a flame. White fumes of sodium chloride are formed. We can write the reaction between sodium metals and chlorine gas, which leads into the formation of a sodium chloride, which is a salt. Lithium reacts less vigorously with chlorine, while potassium reacts more vigorously, as seen also the reaction between a metal, alkali metal and water. Lithium plus chlorine leads to the formation of lithium chloride, which is a metal. Potassium also reacts with chlorine gas, leading to the formation of potassium chloride. Alkali metals react with chlorine gas to form the corresponding metal chloride. The reactivity of alkali metals with chlorine increases down the group. This is because the increase in atomic radius, which leads to the increasing is to lose the electron in the outermost energy level. Alkali metals react by losing the one electron from the outermost energy level to attain a stable electron configuration. They are stable octet, which is whereby the outermost energy level should have the maximum number of electrons 8, so that it can be attained a stable octet or a stable electron configuration. Also, we can talk about similarities of ions and the formula of some compounds of alkali metals. Alkali metal ion, lithium, forms of hydroxide ion, which is lithium hydroxide. Therefore, the alkali metals can react with hydroxide, oxide, and chloride, therefore forming a further compound. Is alkali metal ion combines with a single hydroxide ion to form the respective hydroxide. Therefore, namely, lithium reacts with hydroxide to form lithium hydroxide, which has a symbol that can be written. Sodium also reacts with the hydroxide to form sodium hydroxide. And potassium hydroxide reacts with hydroxide to form potassium hydroxide. This is because the valency of group 1 elements is 1. Therefore, the same applies in the formation of lithium chloride, which reacts with chlorine to form that symbol of lithium chloride. Sodium also reacts with chlorine to form a symbol of sodium chloride, which is a salt. Potassium also reacts with chlorine to form potassium chloride, which is also a salt. Two alkyl metals ion combine with one oxide ion to form the corresponding oxide. Namely, lithium, when lithium reacts with an N oxide, it forms lithium oxide, which has a symbol that can be written also. Sodium oxide reacts with the N oxide to be formed, that is sodium oxide. And potassium reacts with N oxide to form potassium oxide. This is because the valency of oxygen is 2. Therefore, one oxygen ion requires two alkyl metals ion to combine with to form the corresponding oxide. Due to the high reactivity, alkyl metals are not found as free elements. They are normally found in the combined state, the earth class. For the next discussion, we are going to look about uses of alkyl metals. Sodium, therefore alkyl metals, we said earlier, they are group 1 elements, which are sodium, lithium, and potassium. Sodium is used in the manufacture of sodium cyanide for the use in the extraction of gold. Another use of sodium chloride is used as a food. Sodium fiber is used to produce the yellow glow light in the street lights. For the rhodium is used in the manufacture of special high-strength glasses and ceramics. Also, lithium compounds are used in the manufacture of the dry cells for the use in mobile, their cell phones, laptops, stopwatches, and the zero-emission electric vehicles. Therefore, a molten mixture of sodium and potassium is used as a coolant in the nuclear reactors. Molten sodium is used as a reducing agent in the extraction of titanium from titanium 4 chloride. A mixture of sodium chloride, sodium hydroxide, which is known as also the caustic soda, and the carbon disulfide is used in the manufacture of artificial silk called rayon. For the periodic trends of alkali metals, I'm going to talk. They saw trends in physical properties, which we have already talked about. Elements in the same period have the same number of occupied energy level. As you move across the nucleus, the number of electrons in the outermost energy level increases by 1. And also, there are also the trends in chemical properties. all of the elements in period 3, with the exception of argon, burn in the air to form oxide. Metallic elements burn in oxide to form basic oxide. Basic oxides, therefore, for the summary of the alkali metals, it shows that the elements are grouped in chemical families according to similarities in the number of electrons in their shells. Elements react in order to attain a stable electron configuration of a number of gases, which is an octet state. Therefore, for the electronic structure and trend, alkali metals exhibit a regular pattern in electronic structure, e.g., the formation of SPDF. Therefore, for lithium is 2s per 1. For calcium is 6s less per 1. The trend of increasing atomic size and decreasing ionization energy is consequence of the outer electron being further from the nucleus down the group. We can see the summary of alkali metal compounds. Besides forming oxides, alkali metals react with other non-metals to create a variety of compounds. E.g., lithium forms lithium carbonate used in the psychiatric medications, while potassium is a key component in fertilizers through potassium chloride, the fertilizers we use in farming sector. While for the metallic property, for the summary of alkali metals possess a typical metallic properties such as malleability and conductivity. The malleability means that they are not easy to cut. They are soft and can be. The malleability, which means they can be easy to cut. Alkali metals are soft and can be easily cut with a knife due to weak metallic bonding. For the alkali metal alloys, alkali metals can form alloys with other alkali metals or metals of different group. Sodium-potassium alloy is an example with the application in the cooling system and as a heat transfer fluid. In the application of industry, sodium is crucial in the production of soap, detergents. Potassium compounds found used in the manufacture of glass as fluxes and in fertilizers. The biological function of alkali metals, sodium and potassium ions, are essential for maintaining electrochemical gradients across cell membrane. They are vital for nerve impulses transmission and muscle contraction in living organisms. For the summary in the reaction of water, alkali metal react violent with the water, producing hydroxide and hydrogen gas. The reaction becomes more exothermic and explosive down the group. Exothermic means that the temperature within the surrounding increases. And in summary of isotopes of alkali, isotopes and radioactivity, some alkali metals like potassium have naturally occurring stable isotopes. The stable isotope means that they have attained a stable octane in the outermost energy level or a stable electron configuration. Francium, on the other hand, is highly radioactive and has no stable isotope. Flame test and spectroscopy. Alkali metal display unique emission spectra when subjected to flame test. The flame test, which are luminous and non-luminous, they produces different colors. Like sodium produces a yellow flame. Therefore, potassium different flame. While this property is utilized in the analytical chemistry to identify and quantify elements based on their characteristic colors. For the underlying quantum mechanics, the behavior of alkali metals is explained by quantum mechanics, including concepts like electron configuration, orbitals, and energy level. The quantum model provides insight into trends observed in the periodic table. After done with the summary of our topic, we can look for the questions under what we have been discussing since the beginning of the lesson. Some questions that may fall under this discussion. Some more questions like, what is the significance of alkali metals having a single valence electrons? Alkali metals, as we discussed earlier, alkali metals have one valence electrons in the outermost energy level. In this situation, in the equation, we can tackle that the single valence electron in the alkali metals is crucial as it determines their high reactivity and the tendency to form one oxidation state ions. Question 2. How do alkali metals react with water, and why does the reactivity increases down the group? As we discussed above, the reaction between alkali metals and water. The reaction, the alkali metal react vigorously with water, producing hydroxides and hydrogen gas. Reactivity increases down the group due to the electron being further from the nucleus, leading to easier loss of electrons. Question 3. Why are alkali metals stored under oil? The reason why we store some of our alkali metals in oil is because to prevent contact with moisture and oxygen, which they react with rapidly. This helps maintaining their metallic property. There is another question explaining the trend in the melting point of alkali metals as you move down the group. Therefore, from the discussion above, we saw that the melting point and boiling point of alkali metals decreases as we move down the group of alkali metals, because the outer electron is further from the nucleus, resulting in the weaker metallic bonding. This also reduces the force of attraction, holding the electrons within the energy levels together. How do alkali metals form ionic compounds? And what is the common example? Therefore, alkali metals readily form +1 ions by losing their single valence electrons, which is 1. An example is sodium chloride. So when sodium forms a 1 positive ion, there is another question that states for the discussion of the uses of alkali metals in everyday life or industry. Thereby we say that from the previous discussion that sodium and the potassium are used in the various industries, including the production of soap, glasses, and components in certain medications. Another question is that why is francium less studied compared to other alkali metals? From the discussion we have been having from the beginning of this lesson, we showed that for when we were discussing about the alkali metals, we have been discussing only for the 3 metals. That was sodium, potassium, yeah. But we have not been discussing about francium, yet it is a group 1 element. But we have been discussing about lithium, sodium and potassium, the only one which are within the group 20 elements. This is because francium is rare and radioactive, making it challenging to study. If these properties are inferred from the theoretical prediction and limited experimental data. There is another question that says that what happens when alkali metals react with halogens, and can you provide an example? We have not been discussed about the halogens, which are the group 7 elements or group 17. Therefore, we are going to move on our discussion next on it. But for today, we have been looking for the alkali. The halogens are group 7 elements. Yeah, but for the question it says what happens when the alkali metal react with halogens, and can you provide an example? Alkali metals react with the halogens to form an ionic compound. For instance, sodium reacts with chlorine to form sodium chloride. There's another reaction that is a question that says explain the term flame test in the context of alkali metals. A flame test involves exposing a sample for a flame producing characteristic color. Alkali metals exhibit a unique flame colors due to the excitation of electrons. When we burn the different chemicals, they produce different color frames. Like sodium produces a yellow frame. Yeah, potassium produces a purple frame. There's another question that says, how do alkali metals contribute to the alkali metals group position in the periodic table? Alkali metals they share common properties due to their position in group 1, characterized by a single valence electrons, and they have tendency to form a positive ion. That marks the end of our lesson today. Thanks for the cooperation. Thanks for the attention. Thanks for being attentive. And let's prepare for our next lesson, which is going to be about alkaline earth metals. These are group 2 elements. We are going to talk more details on it on our next lesson. Thanks in advance.